These are notes on possible problem with the tolerance between the pinion gear and the two main gears on the transmission half. So note that this spins freely, so that's a nice pass. I'm going to put the motor into the pocket, and I'm going to ensure it's square, as per my previous video, so you can see that it's not really spinning freely. That's not a pass. And I'm going to now rotate the motor, so like this. As I rotate the motor, you'll notice that the performance of the gearbox changes, and I can even find a spot where it jams the gearbox, causing a failure. So this wouldn't be able to run even though it spins. There's too much friction there, and the robot doesn't run very well at all. I believe that this is because of a tolerance either in the motors or perhaps the spacing between the pinion gear and this gear. It may also be because of the crushing effect that we're getting from the heat staking rig. In any case, the solution here is either to use a different motor. So I'm going to grab another motor here and put that in there, and so I still can rotate it some, but you can see that there's no point where I can really get it to stick. A great way to salvage transmissions that failed, even if they have one position where it completely stalls out, like this guy, is if I sit here and spin it, right, I can find a nice spot where it's got very low friction. So that's a pretty good pass right there, even though you know, like about 180-degree rotation or so causes a failure. I don't know if this should be a process change, so assembly process to clarify. So perhaps the worker puts in the motor, spins the gears, feels for that nice free spinning, and then passes it only when it gets there. Or if we should open up the tolerances here, or make sure that the motors aren't being crushed, which may cause some of this deformation. In any case, this is causing a great number of failures. Of the last batch, probably a quarter to a third wouldn't run until I gave them a little bit of work and fixed them up. I'm usually able to salvage them all, though I do have to cut the heat staking and pull them out and spin the motors and find that fit. Between ensuring that the gearboxes are fully pressed together and making sure that this spins freely, like so, we can definitely get the performance we want from this part, but it's a little labor intensive to find that and salvage the part and do the quality control and make sure that we're putting gearboxes, especially if we get a left-right asymmetry, then the robot just runs in circles. So please let me know how you think we should proceed on this, since I think this is the largest current outstanding problem with the gearbox.